Hello 108 students, Mr. McCue here. We're back on section 9.7. We're working on page 3. And now we really just want to get efficient here and take advantage of the interval testing concept, and we're going to work with the same example we've been doing. And we're going to take x squared minus x minus 12, and this time it's going to be greater than 0, and we're going to go ahead without actually graphing it, take advantage of the interval testing concept. And what I found out after looking through the book and stuff, you really can make life efficient for yourself by realizing that interval B, which is the inside or middle interval, is where you want to test first. And many times when x equals 0, that will be inside that interval zone. You let x equal 0 and find out whether it's going to be a true or false statement. So let's just review the steps real quick here. And let's not forget that you have step 1 is to take your quadratic equation, set it equal to 0, and find the roots like we've done before. And that's usually fairly easy. Next step is to make an x-axis and mark the solutions where the parabola will cross the x-axis, and identify the three intervals. A, which will be on the left outside, B will be in the middle, and C will be on the right outside. And then don't forget that when you graph it, you got to remember the A coefficient. In this case up here is a positive 1, is going to open up, which means the vertex will be down below, and then you're going to go ahead and make a pseudo graph of it. Going to test for the middle one, always go for that first. If it ends up being true, then that's the solution. If it's false, you can assume it's the outside, A and C. Okay, so let me see if I can show you guys how to do that here. Okay, so here we go. We're going to use the same example we've been doing before. We've already found that the roots to this problem are, excuse me, I'm having a look, there we go, are going to be -3 and positive 4. So you come over here, and again, we're going to put open dots here because it's greater than. So you're going to put the open dots. We know the graph is going to open up. The vertex is going to be somewhere below. If you want to, you can put a little y-axis here if that would help you. And now you're going to ask yourself, you can identify the intervals. A is on the left outside, B is in the middle, and C is on the right outside. Which if we find the interval B, we're going to go ahead and see what happens here. So what you do is make life easy. Check and make sure that the x-axis, when x equals 0, that it's in the B zone. Usually it is. So go ahead and let x equal 0, substitute it into the quadratic equation, and of course the ax term and the bx will zero out, and you're left with the c. And quickly you ask yourself, is -12 greater than 0? Is that a true statement? No. And so that's a false statement. Therefore, you can conclude that interval B is not your solution set, and A and C are. Now, A and C means you are going to be above the graph, and so you could come back here on your pseudo and then to kind of take advantage of highlighting like I did in black here. You're going to realize you're on the outside zones, A and C, and you're going to write the notation in this format first here with x less than -3, and you're going to union it with x is greater than 4. Remember, you're looking on the x-axis here. Okay, with that said, when you go to set notation, you bring it down, and you would go ahead and go with parentheses because you're not putting the equal sign with the inequality. You're going from -infinity all the way to -3, but not including it. Finally, you union that with -4 going all the way out to positive infinity, and you're not including them. Okay, that's it for page 4 here. I think we're doing pretty good here. We're going to work on page 5, and we're going to work on some special cases on the bottom half of it. Okay, that's all for now here, Mr. McCue, so I will see you here on page 4.